We are on a collision course, a shared plunge towards the massive Andromeda Galaxy, a sprawling collection of hundreds of billions of stars. As the nearest spiral galaxy to the Milky Way, Andromeda has long fascinated astronomers. Historically, it was believed that a collision between our galaxies wouldn't occur for another 4 billion years. However, a startling signal from the James Webb Space Telescope has suggested that this impact may happen much sooner than previously thought. Adding to the intrigue, data from the telescope has unveiled surprising and alarming details about Andromeda's true nature. This discovery has sparked excitement and speculation within the scientific community. Could this be a response to our interstellar communication efforts, or does it signify an unknown cosmic event? Moreover, what will happen when Andromeda and the Milky Way finally collide? Join us as we delve into the unsettling revelations from the James Webb Space Telescope about the Andromeda Galaxy. The Milky Way, our home galaxy, is part of the local group of galaxies and is a barred spiral galaxy. Its galactic center, faintly visible from Earth in the constellation Sagittarius, is a hub of billions of stars. Despite the vast number of galaxies in the universe, the Milky Way took eons to study and understand due to the limitations of early scientific instruments. Initial observations of the Milky Way date back to ancient civilizations. The Greeks named it Galaxias Kyklos, meaning Milky Circle, due to its appearance in the night sky. It wasn't until the invention of the telescope in the 17th century that Galileo Galilei revealed its true composition: countless stars. This marked a significant step toward understanding its structure. In the early 20th century, a debate raged between astronomers Harlow Shapley and Heber D. Curtis. Shapley argued that the Milky Way encompassed the entire universe, while Curtis believed the universe was made up of multiple galaxies like the Milky Way. This debate was resolved in the 1920s by Edwin Hubble, who identified Cepheid variable stars in the Andromeda Galaxy, proving it was a separate galaxy outside the Milky Way. Hubble's work also led to the discovery that the universe is expanding, as evidenced by the redshift of light from Andromeda, a finding that laid the foundation for the Big Bang theory. Andromeda has been known to humanity since antiquity. Persian astronomer Abd al-Rahman al-Sufi referred to it as the Little Cloud in his 964 CE Book of Fixed Stars. However, it wasn't recognized as a galaxy until much later. Also known as Messier 31 M31, Andromeda was once thought to be significantly larger than the Milky Way, an assumption influenced by its striking appearance from Earth. Recent studies, however, reveal more accurate insights into its size and history. Andromeda is approximately 10 billion years old, suggesting a complex development over time. While the Milky Way spans about 100,000 light-years in diameter, Andromeda is a staggering 220,000 light-years across, more than twice the size of the Milky Way. It also contains an estimated trillion stars, compared to the Milky Way's 250 to 400 billion. Despite its serene appearance to the naked eye, Andromeda has a tumultuous past and a dynamic future. One of Andromeda's most fascinating features is its active galactic nucleus, AGN. This region, powered by a supermassive black hole at its core, emits strong radiation across various wavelengths, including X-rays and radio waves. The black hole is estimated to have a mass between 110 million and 230 million times that of the Sun. It exerts immense gravitational forces, influencing the orbits of nearby stars in a manner similar to planets orbiting their stars. These interactions, particularly at the closest orbital point known as periapsis, showcase the black hole's intense gravitational pull. A compelling hypothesis about Andromeda's formation suggests it was created through the merging of smaller protogalaxies over billions of years. This gradual process, driven by gravity, transformed it into the spectacular galaxy we observe today. Such mergers are common in the universe and play a key role in shaping galaxies. Recent observations from the James Webb Space Telescope hint that Andromeda may be undergoing a significant transformation. The data indicates a potential shift from a traditional spiral galaxy to a ring galaxy, characterized by distinct structures of bright, young stars forming circular patterns. This rare and striking phenomenon has captured the attention of astronomers, further highlighting Andromeda's dynamic nature. The telescope's findings also reveal similarities between the histories of Andromeda and the Milky Way. Both galaxies have experienced major accumulation events that shaped their inner halos. Scientists predict that the eventual collision and merger of Andromeda and the Milky Way will create a new supergalaxy. For now, Andromeda continues to captivate and challenge our understanding of the cosmos, with every discovery offering new perspectives on the vast and complex universe we inhabit. The universe is currently moving toward our Milky Way at a speed of around 200 kilometers per second. Based on this, scientists predict that the eventual merger of our galaxy with the Andromeda Galaxy will take place in about 4 or 5 billion years. However, recent evidence from the James Webb Telescope suggests this interstellar collision could occur far sooner than previously believed. So why is this happening? The main reason the Milky Way and Andromeda galaxies will merge is because they became gravitationally bound to each other long before dark energy began dominating cosmic expansion. It is now widely accepted that this colossal event has been given nicknames like Mila or mild Roma. Despite these intriguing names, the impacts of such a merger would be catastrophic for human civilization. As the two galaxies approach one another, their powerful gravitational forces will begin to warp each other's shapes. Although stars in each galaxy are spaced far apart, making direct collisions unlikely, some stars may be ejected due to the interaction. Proxima Centauri, for example, the closest known star to our Sun, is about 4.2 light-years away. While stars tend to be more concentrated near the cores of their galaxies, the average distance between stars is still vast, around 100 billion miles. Therefore, it's highly improbable that any individual stars will collide. However, it's possible that some stars could be flung into space. Both the Milky Way and Andromeda have supermassive black holes at their centers. Over millions of years, these black holes will begin to spiral toward one another, eventually merging at the center of the newly formed galaxy. These massive black holes will emit gravitational waves, ripples in the fabric of spacetime, caused by some of the most violent and energetic processes in the universe. Albert Einstein predicted these waves in 1916 through his general theory of relativity, and their detection has provided astronomers with new tools to study cosmic phenomena that were previously hidden from view. As the supermassive black holes draw closer, their intense gravitational forces will create significant distortions in spacetime, producing gravitational waves that radiate outward at the speed of light. The strength of these waves will increase as the black holes get closer, leading to a spiraling effect that continues until they are within 1 light-year of each other. At this proximity, the gravitational waves become extremely powerful, emitting orbital energy and causing the black holes to spiral even faster toward their inevitable collision. The merger of these supermassive black holes is an event of immense magnitude. As they merge, their intense gravitational forces will attract nearby gas and dust, creating a thick, rapidly spinning accretion disk. This disk will become incredibly hot and energetic, emitting vast amounts of radiation across the electromagnetic spectrum. Additionally, the black hole merger will produce a final, powerful burst of gravitational waves shortly before they collide, a signal that observatories on Earth can detect, providing valuable insights into these extreme conditions. The final collision of these supermassive black holes will release an enormous amount of energy, comparable to the combined energy output of all the stars in the observable universe. This energy will primarily be emitted as gravitational waves, but also as electromagnetic radiation, including X-rays and gamma rays. The merger will likely result in a single, much larger black hole surrounded by the remnants of the accretion disk, and possibly high-energy particles traveling near the speed of light. The material that these merging black holes consume could form an active galactic nucleus, AGN, one of the brightest and most energetic objects in the universe. The newly formed AGN at the center of the merged galaxy will emit extreme radiation, potentially outshining the rest of the universe and affecting star formation and other cosmic processes. The energy released by the AGN could drive powerful winds that blow gas out of the galaxy, potentially halting star formation and altering the galaxy's evolution. The creation of an AGN would mark the beginning of a new phase in the life of the combined galaxy. The energy and radiation from the AGN could shape the galaxy's structure and influence the behavior of stars and gas over time. While the AGN may eventually become less active as it consumes available material, settling into a quieter state. The impacts of the black hole merger and the subsequent AGN activity will leave a lasting imprint on the galaxy. These changes will shape its appearance and behavior for billions of years to come. The merger of supermassive black holes in the newly formed galaxy will be a cataclysmic event, producing powerful gravitational waves and electromagnetic radiation. The resulting active galactic nucleus will serve as a beacon of energy, shaping the galaxy's evolution and leaving a significant mark on its structure and behavior. This dramatic cosmic event will not only transform the galaxy but also provide astronomers with a unique opportunity to study the most extreme conditions in the universe, enhancing our understanding of black holes, galaxy formation, and the fundamental nature of spacetime. You might be wondering, what will happen to our solar system? Current calculations suggest there is a 50% chance that our solar system will be swept far beyond the galactic center in the merged galaxy, farther than it is now. The Sun resides in a part of the Milky Way known as the Orion Arm, which branches out from the galactic core. If we are pushed further away, researchers estimate that there's a 12% chance that our solar system could be entirely ejected from the new galaxy at some point during the merger. So what about life on Earth? In about 7.5 billion years, the Sun will expand into a red giant, swallowing the Earth and transforming it. However, even before then, the Sun's natural luminosity will rise, causing Earth's surface temperature to increase. We could experience a runaway greenhouse effect similar to what is happening now on Venus. Therefore, it's likely that life on Earth won't survive after the merger. Unless, of course, humanity has developed space travel by then. It could be possible that some people will have left Earth in our solar system, and the view of Andromeda colliding with the Milky Way may still be visible, just from a slightly different perspective.